exponential function. So this term is also linear. Last term, third one is also linear. Right in a function, but since it is appearing with independent variables, so it is allowed. If it would be cos y, then it would not be a linear anymore, since cos is a non-linear function and appearing with dependent variable y, so that would be in that case a non-linear ordinary differential equation. So if equation is not linear, so it will be called non-linear differential equation. So for non-linear equation, we see that there are some properties, same properties as I have discussed. Same properties as I discussed previously. Dependent variable and or its derivatives are of degree greater than 1. And/or means that may be possible that dependent variable and derivatives both are present there, so you will check both. If any one is present, so you will check that. Whatever is present, whether dependent variable is there in the equation or its derivatives are there in the equation, degree of each term with dependent variable and its derivative should be greater than 1, so that the equation will be non-linear differential equation. Products of dependent variable and or its derivatives occur, again as I explained, that if it is a non-linear differential equation, then you may find the products of dependent variable, you may find products of its derivatives. And the third point is transcendental functions of dependent variable and its derivatives are present. Just like I told you, if instead of cos x, it was cos y, so it will be a non-linear differential equation. Just like this example number 9. It is a differential equation. It is ODE. 3 primes are representing third order derivative. So equation number 9 is third order ODE. Now the question is this linear, non-linear?
Non-linear.
Why non-linear? Reason?
It is containing the product of also containing the pause because it is divergent.
Right. Right. Equation number 9 is non-linear because it has product of y and its derivatives also. Like if you observe first term, so product of dependent variable and its derivatives is present. That is why it is a non-linear differential equation. Plus cos y, trigonometric function or transcendental function is present with dependent variable, so it is also a non-linear differential equation. Before going to the solution of differential equation, I would like to discuss some more examples. Okay, so if you look at all these examples I have written here, these are examples of an equation, not a differential equation. These are simply equations of one variable, two variables, three variables, and so on. If we look at 3.11, so 3.11 is first order ODE degree 1. It is a linear equation because the first term do not contain any product of derivative. It does not contain any rational power of derivative. Plus this equation do not contain any tile function with dependent variable y. So 3.11 is representing first order ODE with degree 1 and it is a linear equation. Right? So I am writing L in front of it. Now check 3.12. 3.12 is linear or non-linear?
Non-linear.
Okay.
Non-linear.
If non-linear, why non-linear? If linear, why linear? Give answers one by one.
Miss 3.12 contain exponential function e. That's why it is non-linear.
Okay. So tell me that exponential function appears with independent variable or dependent variable?
It's a linear.
It's a linear. Why linear?
Because the exponential function is not the dependent variable. X is not dependent variable. X is independent variable. Y is dependent variable.
Right. In example 3.12, y is dependent and x is independent. So exponential function is appearing with independent variables, so it is allowed for differential equation to be linear. It would be non-linear if exponential function would be appearing with dependent variable or its derivative. Instead of x, if it would be y, or it would be e power y prime, or it would be e power y square, then we would be considering it as a non-linear differential equation. So since exponential function or transcendental function is appearing with independent variables, so it is allowed, and y prime is appearing with one power, or in other words, degree of this equation is 1. So it is also a linear differential equation. 3.13 is also linear. Okay. 3.14.
Is also linear.
It is also linear. Function is unknown, but still we can identify it as linear, non-linear. Why? Because it is not appearing with any product of dependent variable. It is not appearing with any rational part. No trigonometry function is there. So it is simply a linear equation. Similarly, if I talk about 15 is also linear. What about 3.16? Linear or non-linear?
Linear.
If linear, y linear. If non-linear, y non-linear. Answer one by one. Those who are saying linear, so why it is linear? 3.16.
It is linear because it is multiplied by independent number 3. It is not multiplied with any dependent or independent variables.
Okay, anyone else? All of you agreed with the statement that y prime is multiplied by 3, so it is a linear equation. Those who are not asking anything, those who are not replying to the question, they should mute their mic for the smooth continuation of the class. CR would answer whether 3.16 is linear or non-linear. If linear, y linear. If non-linear, y non-linear.
It's linear
It's linear. Why linear?
because प्लस डिपेंडेंट वैल्यू से y मल्टीप्लाई नहीं हो रहा है और इसमें कोई टाइप फंक्शन भी नहीं लग रहा.
Okay. So what do you mean by cube here? 3y prime whole cube. If you simplify it, what would you write? You will write 3y prime multiplied by 3y prime multiplied by 3y prime. Is it so? We have cube power on y prime. Y prime is the derivative of dependent variable and we have cube power of it. It means y prime is multiplied with y prime itself 3 times. Y prime multiplied by y prime multiplied by y prime. So it has a non-linear power. So it is a non-linear equation. Right. Now similarly, if we check 3.17, so in 3.17, highest order derivative is 3. So it is third order ODE. Degree is degree what is in 3.17? Degree is 2, right? Because 2 is the power of the highest order derivative. It is non-linear. Why non-linear?
Because y prime is multiplied by itself.
Right.
Y prime multiplied 4 times itself.
Exactly. Third order derivative term is also appearing with greater than 1 power. Similarly, y double prime is also appearing with greater than 1 power. So it means it is a non-linear equation. What about 3.18? It is linear, non-linear.
Non-linear.
Yes.
Why non-linear? Okay, I'm writing here non-linear.
Because y prime is multiplied by 5 times itself.
Right. If you observe, right, if you observe third term in 3.18, so third term in 3.18 is x y prime whole power 5, which means y prime is multiplied itself, which is dependent derivative of dependent variable is multiplied with itself 5 times. So it is also a non-linear equation. What about 3.19?
It's a linear equation.
It's a linear equation. 3.20.
It's not a linear equation.
It is not a linear equation. Why not? if you observe 3.20, so y is dependent variable, x is independent. So if anything else is appearing, so that is just like constant.
That's why it's a linear.
Okay, is a linear equation. And what about 3.21? 3.21 is
Non-linear.
Non-linear.
non-linear because
Both variables are
Power square, pi square.
Independent, both are multiplied by.
yes. This term, if you observe minus 2xy dy, so no matter here we have xy are appearing as a product, but x is independent. But this one is non-linear because of the presence of y square. Y is the dependent variable, we have a square on it, so it is a non-linear equation. Let's move further. We were discussing so far linear, non-linear differential equations. Now solution of a differential equation. If we simply talk about solution of an equation. So we know that solution of an equation is a value just like y is equals to 4 plus y is equals to 4 plus 2y. Equation is there and we have to solve it. So it means y is unknown in this case. So for one variable, if I talk about solution of an equation is the value which satisfy the equation. Value which satisfy the equation, it means when I substitute that value into the given equation becomes identical. Identical means left hand side becomes equals to right hand side. Similarly, when we talk about solution of a differential equation, so solution of a differential equation is that function when we substitute it into the differential equation, it becomes identical. So any function when substituted into the given differential equation becomes identical or makes left hand side is equal to right hand side. So that is called solution of a differential equation. We have two types, general solution, particular solution. General solution, by the word, it is clear that any function, first we discussed that any function which satisfy the given differential equation or which makes the equation identical, means when I substitute function in the differential equation, left hand side would be equal to right hand side. That is called the solution of a differential equation. Then I said that solution can be general solution can be particular solution. We categorize them into two, general solution and particular solution. If that function or expression contain arbitrary constant and is still satisfying the differential equation, so that is called general solution. If arbitrary constant means unknown constant, just like c or k or anything is present which you don't know the value of, so we say it is a general solution. And particular solution means that if there's no arbitrary constant in the function and when you substitute it into the differential equation it satisfies, so we call it particular solution, right? So general solution means the function which contains some arbitrary constant. Arbitrary constant means unknown constant is still it is satisfying the given differential equation. So we call it general solution of a differential equation. If that function does not contain any unknown constant or arbitrary constant and satisfying the given differential equation, so we say it is the particular solution. Look at this example. Y is equals 2 plus k e power minus x. This equation, which is y is equals 2 plus k e power minus x, shows that y is dependent variable, x is independent. When y is dependent, x is independent, k is a constant. K is constant, we know, but we don't know what is the value of k. So we say that k is an arbitrary constant, right? Arbitrary means your choice. If there are, let's suppose 56 students sitting in a class, so each student can pick up different value of k, right? Here 58 students can substitute 58 different values of k and obtain 58 different solutions. So each solution for a distinct value of k will be called particular solution, and since all those 58 solutions are derived from this solution, so it is called general solution. So in simple words, we say if any function contains arbitrary constant, still it is satisfying the differential equation, so that is called general solution. Now I have cleared that why we are calling it general solution, because this constant is unknown. You can substitute different values of A and you can obtain different solutions. Since all solutions can be obtained from here, so this is called general solution, and the solution for any particular value of K, that will be called particular solution. Now what you have to do is you have to write down this equation first. Y is equals to 2 plus k power x. It is given that this function is the solution of this differential equation. So quickly verify that this y is equals to 2 plus k e power x is satisfying this differential equation or not. How will you check? You will substitute y here and you need to differentiate this equation with respect to x to get y prime. Then you will substitute y prime plus y is equals to 2. When you will substitute it here, so left hand side should be equals to right hand side. Then you will say that it is the solution of given differential equation. So quickly write down the equation y is equals to 2 plus k e power minus x and check whether it satisfies the equation or not, or maybe I have done some mistake and I have written that is the solution. Quickly, all of you should solve it. How will you solve? You will simply substitute this function into the given differential equation. If equation become identical or left hand side is equal to right hand side, then we can conclude that yes, that the given function is the solution of given differential equation. So quickly note down the differential equation, note down the function, and verify that it is a solution or not. All of you should try.
Yes, miss. It's answer 2.
It is satisfying.
Yes, miss. It is satisfying.
Okay. PR. PR has done or not? Quickly perform the calculation. You simply have to substitute it.
Yes, it is easily done.
It is done. You simply have to replace y in the given differential equation by the given function, and then you will differentiate the given function with respect to x to get y prime. Substitute both y prime and y in the differential equation. Left hand side should be equal to right hand side. Done?
Yes.
Okay. So we have seen that if we substitute y is equals to 2 plus k e power minus x in the equation y prime plus y is equals to 2, it is satisfying the equation. So we can say it is a solution of differential equation. And which type of solution? It is a general solution of differential equation. Why general solution? Because k is appearing here, which is unknown constant or arbitrary constant. Okay. As I told you that substituting different values of k, you can obtain different solutions. So every solution which is obtained by substituting some particular value of k, that will be called particular solution. And the graph of particular solution will be called integral curves. Just like the graphs you can see, these graphs are plotted for different values of k. These graphs are representing the graph of solution of the previous equation which I just showed you for 4 different values of k. These are 4 different solutions. It means each of the curve is representing a particular solution to the given differential equation. So this curve is called integral curves. Right, okay, before moving to initial value problem, let's discuss some more examples, just like here. If you can see equation 3.3, consider the algebraic equation x square minus 2x minus 3 equals 0. We have given an algebraic equation in 3.3. We say that when x is equals to 3, so 3 will satisfy the equation. So 3 is a solution. Solution means when I substitute x is equals to 3 here, left hand side will be equals to right hand side. Similar, as I told you, that similar is true for a differential equation. If f of x, f is a function of one variable. Here we have an example, y is equals to f of x is equals to ln x plus x, where x is greater than 0. We say that this y is equals to ln x plus x is the solution of this differential equation. What is the differential equation? X square y double prime plus 2x y prime plus y is equals to ln x plus 3x plus 1. Quickly verify this question also. What do you have to check? You have to check that the function given in 3.31 is the solution of differential equation 3.32 or not. If 3.31 is the solution of 3.32, so it should satisfy this equation. Satisfy this equation means when I substitute 3.31 in 3.32, so left hand side will be equal to right hand side. How will I substitute? If you observe equation 3.32, so first term is x square y double prime. It means you need second order derivative of this function. So differentiate this equation 2 times. Second order derivatives will be substituted here. First order derivative will be substituted here. By this function will be substituted here. Then simplify the equation. Left hand side should be equal to right hand side, or equation should become identical. So we say that the given function 3.31 is the solution of 3.32. Quickly verify that this is the solution to it or not. All of you should note down this equation 3.31 and check out that the function in 3.31 is the solution of 3.32 or not. It will be a solution if it satisfies the equation. Here is a call for prayer, so I'm taking 2 minutes break. Till then, you people can continue solving and checking whether it's satisfied or not. After call of prayers, we will continue. After 2 minutes, stay connected, do not go anywhere.
Please display the PDF so I can take the picture.
All right. Tell me that, have you checked that this satisfying the equation or not?
Let us find that ln x plus x plus 3x.
Okay, so left hand side is also same, ln x plus 3x plus 1.
Miss 3 is there, 3 is the addition. 3 is not in the answer of us.
Okay, it means it is not satisfying.
Yes, miss.
It is satisfying.
It must be satisfying. I have also checked.
It is satisfying the equation.
Yes, it is satisfying. Okay, y is equals to ln x plus x. This is one equation. If you differentiate this equation y, which is 3.31 with respect to x, so you will get y prime. Y prime will be derivative of ln x is 1 over x plus derivative of x is 1, which is your second equation. All of you have the same derivative, first derivative. First derivative is 1 over x plus 1.
That one.
Right. If we find second order derivative, so in second order derivative, since first term is 1 over x will be shifted in numerator, power is minus 1. So second order derivative or derivative of 1 upon x will be minus 1 upon x square, and derivative of 1 is 0. First tell me that second order derivative of all of you is minus 1 upon x square.
Yes, ma'am.
Right. Now substitute all. We have equation x square y double prime is minus 1 upon x square. Then plus 2x as it is from the equation. Y prime is 1 upon x plus 1. Then plus y. Y is ln x plus x equals ln x plus 3x plus 2. Now simplify it. Right? This satisfying.
I've done the mistake in plus 1. That's why
You have got your mistake. Okay. So since substituting 3.31 in 3.32, it is satisfying or equation becomes identical. So we say it is a solution to the given differential equation. Is it a general solution or a particular solution? Who will answer me that it is a general solution or it is a particular solution of a differential equation?
Maybe it is particular solution.
Why it is particular solution? Why do we say it is a particular solution?
Yes, because there is no constant there, and if the constant is present, then it should be only one, because it does not disturb the equation.
There is no unknown constant, right?
Yes.
Constant can be present in the solution, but there is no unknown constant, which we call arbitrary constant. Since there is no unknown constant or
Yes,
arbitrary constant,
where is
that's
constant in this
why
equation?
constant is not present, but constant may be present. So
Yeah.
we cannot say just because constant is not present, it is a particular. If
Yes.
there is no arbitrary constant, then it will be called particular solution.
Yes, that's the matter
Right?
I'm
So particular solution, okay, particular solution may contain any constant just like plus 1. I can write plus 1, plus 2, 35, minus 35, anything. But since it does not contain any unknown or arbitrary constant, so that is why we are calling it a particular solution. Okay. Then we have another example was here. X the simplest solution. Verify that the function defined by this is the solution of the differential equation. Example 1.3.1. If we observe y is equals to x square is given a function and x is minus infinity to infinity, it means all real numbers in the domain of this function. Verify that the function is the solution of differential equation. If this function is the solution of this differential equation, so it should satisfy it. Right? So if we substitute second order derivative here, first order derivative here, left hand side should be equal to right hand side. You can see that by a, the function f of x is equals to x square, f prime will be 2x, f double prime will be 2. If we substitute all, so it will be satisfied. 8 minus 8 will be cancelled out, plus 4x square minus 4x square, it will satisfy the equation. So I hope that now solution is clear, that what is the solution of differential equation, what is general solution, what is particular solution. One example we have done with the general solution in which k was appearing, and one example we have done with particular solution. Previous one and this one is also a particular solution because no arbitrary constant is appearing here in equation number 8. Let's move further.
Please, you can verify. You can please give one example more for general and for particular.
This is also an example of a particular solution. Why particular solution? Because here y is equals to x square is given. There's no arbitrary constant. Arbitrary constant, let me show you an example. What is arbitrary constant? If you observe this, we have already seen that y is equals to 2 plus k e power minus x is the solution of this equation. Whereas we don't know that what is this constant equals to, but still we have checked that this is satisfying the given differential equation. It means k is an unknown constant. This unknown constant can be substituted as any value. Just like if I ask you all, substitute one value of your choice as k and find out the solution. So every solution that is obtained by substituting some particular value of k, that will be called a particular solution. Getting it? Since arbitrary constant or unknown constant is present, so that is why we call it a general solution.
Yes, I certify.
Right? If let's suppose k is not present, so it would be y is equals 2 plus e power minus x. In that case, there would be no unknown constant or arbitrary constant. In that case, it would be representing a particular solution to the given problem.
Yes, let's clarify it. Thank you.
Good. So we discussed about the solution, we discussed about general solution, we discussed about the particular solution, and the graph of every particular solution is then integral curve. Right, this is what we discussed. Now IVP, which stands for initial value problem. A differential equation together with a specified value of unknown function and or its derivatives at a given point in the domain solution. In simple words, we say that it must be clear from the word initial. Initial means something to start with, right? If differential equation is given with initial condition, so we say that it is initial value problem or IVP. Now the question is, what is initial condition? Initial condition is some particular value of dependent variable and its derivatives at only one value of independent. Just like if you observe example number 10. We have given a differential equation, first order ordinary differential equation, y prime is equals to a y minus h. Y is dependent variable, x is independent, so a and h are representing constants here. Instead of x, okay, we have t as a variable here, so t is independent in this case, y is dependent, so all other variables appearing here, they are termed as constant. So a is constant, h is constant. It is first order ODE. It is given that y prime is this, whereas some condition is also mentioned here. This means that y, which is dependent variable, at t naught, where t naught is some value of independent variable, is equals to y naught. It means we know the dependent variable at some particular point of independent variable. This type of condition is called initial condition. And whenever the differential equation is given with initial condition, it is together called initial value problem. If I say another example here, let me check out any example given here with this. Okay, general solution as you were asking, so you can see that this type of constant can also be present in that. Okay, I should write it down myself. Okay, I'm writing here. Let's suppose this differential equation is given to us, y double prime plus y minus x square minus 2x, and it is also given that y at 1 is equals to 0. Wait a minute. Let me explain and I'll take questions also. Then y prime at 1. These are brackets. Bracket shows that we are computing this value at some particular point of independent variable 1. Here we have given a differential equation which is second order ODE. Along with it, two more equations are given which says first equation shows that y, which is dependent variable, is 0 when x is equals to 1. Second equation shows y prime means derivative of y is equals to 1 when x is equals to 1. So here what we have given dependent variable and its derivatives for same value of x. It means independent variable is only 1. So that is why we call it initial value. We just know the initial point to start with. We don't know that from x is equals to 1 we are moving there. We don't know the boundary. So any differential equation along with initial condition will be called initial value problem. If let's suppose y is given at 1, let's suppose it is 1. This an example only, not necessary 1 and 0 are used. It can be any value, positive, negative. Y may have any value, positive, negative. So not necessary that every time we have 0 and 1. Right? So I'm writing another example for this to clear the concept of initial condition. If you look at the second example, in first example, differential equation is given with two conditions. First condition is dependent variable is 0, which is y is 0 at x equals to 1. Second equation shows that y prime means derivative of dependent variable is 1 when x is equals to 1. We observe that in both of the conditions, dependent variable and derivative is known at same value of x. So we say it is initial condition. Now look at the second example. In second example, y is representing dependent variable. It is given that y is equals to 0 when x is equals to 1. Second equation shows y prime is equals to 0 when x is equals to 2. So if you observe the second example, in second example, first condition is given when x is equals to 1 and the second condition is given when x equals to 2. It means dependent variable and its derivatives are known for two different value or two distinct value of x. So now we have a boundary, x is equals to 1, x equals to 2. We have to start from x equals to 1 and we have to end up at 2. So this equation is not initial condition. First one is an example of initial condition because we just know y value, we know y prime at single value of x, which is initial value. So we say it is initial condition, and initial condition along with differential equation is called initial value problem. Similarly, if you look at second example, in second example, dependent variable and derivatives are known or given at two distinct values of x. So we say that it is given a boundary and we have boundary conditions instead of initial condition. So boundary condition along with differential equation is called boundary value problem. Let me show you just like here. Differential equation together with the set of specified values. Specified values means some constant values or some known values of unknown function. Unknown function means dependent variable and or its derivatives at extremes or boundaries. Just like here, another example, differential equation is given. Along with differential equation, two more equations are given in which y is given some particular value 1 when x is 0 and y prime is given some particular value -1 when x is pi by 2. If you observe, dependent variable and its derivatives are known at two distinct values of x. So we say it is boundary condition, and boundary condition along with the differential equation is boundary value problem. Now you can ask the questions about boundary value and initial value if there's any query. First of all, the need to understand initial value problem and boundary value problem is that you should understand what is initial condition and what is boundary condition. So initial as a word gives the sense that initial means something to start with. So initial condition, you will know only one value of independent variable. And boundary means where you know where to start, where to end. So in boundary condition, you know where to start and where to end. It means you have two distinct values of x or two distinct values of independent variable. So that will be boundary condition. Differential equation with initial condition is called initial value problem, and differential equation with boundary condition is called boundary value problem or BVP. Now ask me your questions. Those who have any query so far, let's have a recall to all the things we have discussed so far. We started with what is an equation. Then we discussed differential equations and how to identify that the given equation is differential equation or not. Then we discussed types of differential equations in which we found that we categorize them according to types as ODE and DDE. Ordinary derivatives are present in a differential equation, so ordinary differential equation. Partial derivatives are present in a differential equation, so partial differential equations. Then we discussed order of a differential equation. So highest order derivative term appearing in a differential equation is order of a differential equation. Then we discussed the degree of it. So degree is the power of highest order derivative appearing in a differential equation. What did we discuss next? We discussed the linearity and non-linearity of it, solution of it. That what is the solution of a differential equation? Solution is a function which satisfies the equation or makes the equation identical, right? And then we discussed that we have two different types. We discussed that we have two different types of solutions, either general solution or particular solution. So general solution contain arbitrary constant and particular solution do not contain any arbitrary constant. Then linear, non-linear, just like similar concept for linear equation, that any differential equation is said to be linear if it does not contain product of dependent variable and its derivative, if it does not contain transcendental functions with dependent variable and its derivative, and if it does not contain any rational power of dependent variable and its derivative. So we say that this differential equation is a linear differential equation. Then we discussed about non-linear differential equations. Those differential equations which are not linear, they are called non-linear differential equations. Then after linear, non-linear, we discussed about integral curves. Integral curves are the graphs of each particular solution to the given differential equation. And we also discussed about initial value and boundary value problem. Initial value problem are those. Initial value problem is a differential equation along with initial condition is called initial value problem, and differential equation with boundary condition is called boundary value problem. So initial condition, as I explained, The initial condition is a condition in which your dependent variable and its derivatives will be known for only one value of independent variable. Whereas if your dependent variable and independent variable are known for two distinct values of independent variable, so we call it boundary condition, just like it is clear from the word boundary that you know the starting and ending point. So we call it boundary value problem. So now you people can ask one by one if there is any query that if anyone has some problem or query in order to understand any of the things we have discussed so far, then I'll call it in this today.
Miss, can you please repeat the properties of linear differential equation?
Linear differential equation. Okay. First tell me, Hamza Ahmed, that linear and non-linear equations are clear.
Yes, ma'am. But I don't get the concept of properties of linear differential equation. Can you please repeat them? So can I write?
Yeah, sure. If let's suppose the properties of linear equations are cleared, so similar properties are true for differential equations. But when we look for these properties in a differential equation, so we focus on dependent variable and its derivatives appearing in a differential equation. So let's suppose if an equation is given and you need to identify whether it is linear and non-linear. So for that, the dependent variable and its derivatives. I'm using the word dependent variable and its derivatives again and again, so that not necessary that y is always the dependent variable. I can give equation in terms of t, x. I can give equation in terms of z and x. I can give equation in terms of xi, eta. So with respect to derivatives, you have to identify that which variable is dependent and which is independent. This is one thing. In order to check that the differential equation is linear or not, your terms in which you have dependent variable and its derivatives should have these properties. Which property? Dependent variable should not appear as a product. Dependent variable and its derivative should not appear as a product. Dependent variable and its derivative should not appear with transcendental functions. It means if cos y is present, sin y is present, and y is dependent variable, so your equation is non-linear, right? So tile functions or transcendental functions should not be present for dependent variable and its derivatives for a linear differential equation. This is second property. Third property says that differential equation is linear if your dependent variable and its derivatives are free from rational or radical parts, right? So if let's suppose your equation is y double prime plus x into y prime into y is equals to cos x. So cos x is a trigonometric function or transcendental function, but since this cos is appearing with x, which is independent variable, so no problem, this is allowed. But if this trigonometric function would be appearing with dependent variable or in its derivative, then it would be a non-linear term, right?
Okay, ma'am.
So
Thank you so much.
Every differential equation is said to be linear if dependent variable and its derivatives are not appearing as a non-linear term. And non-linear term means that dependent variable and its derivatives should not appear as a product, should not contain any trigonometric, inverse, Lagrangian exponential function, should not appear with rational parts. If trigonometric function or transcendental functions, products, and rational parts are appearing with independent variables, so that is allowed. Still, it will be called a linear differential equation. But when you check the linearity, non-linearity, you target on your derivative terms, means dependent variable and its derivatives. Now ask if there's any other question. 64 students are here. 54 students. Okay, initial value problem. Initial value problem is a differential equation with the initial condition is called initial value problem or IVP. Now the question is, what is initial condition? Initial, as the word gives the sense that you have some starting point, or you know some starting point, or you know the point to start with. So initial condition will be the value, particular value of dependent variable, again y, and or its derivative, which is y prime, y double prime, or y triple prime. Some particular values of dependent variable and or its derivatives will be given for only one value of independent variable. If along with differential equation you are given some particular values of y and or its derivatives for only one value of independent variable, so your condition will be initial condition. Initial condition plus differential equation is initial value problem. Similarly, boundary value problem. For boundary value problem is a differential equation along with boundary condition. And now boundary, so it means now we know where to start, where to end. It means instead of one, you have given two distinct values of x or independent variable. You will be given some particular values of dependent variable and derivative for two values of independent variable. If you know that particular value of y and its derivatives at two distinct values of independent variable, then we say it is a boundary condition. Boundary condition plus differential equation is boundary value problem. When I discuss questions in class and how to solve these, so it will be more clear that how do we know these values and how do we are applying to it. But so far, just to have an idea that what is IVP, PVP, this is also enough.
It can be more than two.
What?
It can be more than two in boundary condition.
Okay, yes. You are talking about the conditions. Yes, conditions can be more than two also. But independent values will be two only. Conditions can be four, conditions can be five, but the independent value will be only two. Anyone else? No question? Give me a minute. Let me have some water. So if anyone has to ask question, you can start one by one. Whoever is not present right now in classroom will be considered as absent. So far, I do not have your list. So I'm just taking a snapshot of the list I have here. Next time onward, I call attendance by your name or seat number, because in next class I will have on-site class in your department, from where I'll receive the attendance sheet, and then inshallah next time onward I'll call you by your names and your seat number. So it would be easy for me also and for you also to note me down your attendance. Okay, any other questions to quickly ask? Then we are going to wind up the session. Let me tell you, since we are going on a hybrid mode of teaching, so we will be having alternate weeks online on-site classes. Next one day we will have on-site class, means in your campus, your department, 3:30 to 6. This week was online week, so I have taken an online class. All those students who belongs to section B, only those students will take my class, whether online or on site. And all students are required to attend online sessions also and on site too, as you have to maintain at least 75% attendance to appear an exam without any fine. If your attendance is below 60%, you will not be eligible to appear in final exam. Keep in mind that below 60% attendance student will not be allowed to give paper, will not be eligible to appear in exam. And 60 to 74 percentage students will be giving paper after going through the fine procedure, and at least 75% attendance if you have. So you will be sitting in exam without any fine. This was also the important thing to discuss with you. Books I have shared, course outline I have shared. Course outline contains only main topics. Every topic has so many subtopics inside. So this is a huge course. So that is why I suggest that keep doing everything time to time. As far as marks are concerned, so I'll divide this 100 marks course into 20, 80. 20 will be the assignment and 80 will be your final exam. Assignment is all practice problems I am providing or I am asking you to do. That is a part of assignment. Assignment you will start doing right now till the last date announced. All practice problems I am marking, I am providing. That is a part of your assignment. Assignment you will do time to time, but you will keep your assignments with you. You have to submit the PDF of the assignment at the end of the semester. I'll announce the date. I give at least a week before I announce the date, and you will have to submit your assignment, right? Since you have to submit the assignment in PDF, so let's suppose you have done exercise 1.1. So take the pictures of that 1.1 exercise questions and then save it as a PDF file as 1.1. And if you have done 1.2, do exercise question or assignment questions of 1.2 and save the PDF by taking pictures as 1.2. And in the end, when all of the exercise PDFs will be collected, then you can make a zip file or you can make one folder in which all the exercise PDF will be given. And then you can upload that in Google Classroom. Okay, so I'll not accept any hard copy of assignment. Assignment has to be submitted in a PDF at the end of semester. So now you know that 20 marks are in your head, that giving assignment, complete assignment and correct assignment, you will deserve 20 out of 20. But if assignment is not complete, is incorrect, so you will not get 20 out of 20. That will be given according to the performance and assignment. Now, if anyone has still any query about assignment or anything, so you can ask. No query, assignment is clear to everyone.
Yes, ma'am.
Okay, so far we haven't done the solutions of it, so I am not marking a question, but I'll see. You can also open a book and see if there's any question to identify, because so far with the knowledge whatever we have shared today, you are able to identify that the given equation is a differential equation or not. You are able to identify the degree order of a differential equation. You are able to identify the equation's PD or ODE. You are able to check out if the given function is a solution or not. You are able to identify whether it is a general solution or particular solution, and you are able to identify this linear and non-linear equation. So I think you should open a book and go to the topics of differential equations and then check out that are there some questions related to this information. If there's so you should try to attempt. I'll also check if I find some exercise related to identification of a differential equations, related to order of differential equation, degree of differential equation, linearity, non-linearity. So I'll also share with you. So that's all for now. If there's no question, so we can wind up the lecture. Is there any other question related to lecture or assignment? Assignment is clear. All of you will submit the soft copy in terms of PDF and you will upload in Google Classroom. You will not upload your assignment after every week. You have to keep collecting with you. At the end of semester, I'll announce the date, at least 1 week I'll give you. Then you will submit your assignment in a PDF through Google Classroom. anyone, whether regular or repeater, can join my Google Classroom and they can stay in touch with all the updates of the course. Even if they are repeater of your section, you can give CR can share the link of this classroom to the repeaters of your section only, so that they can join and they can be updated also with the assignment or with the lectures I'm discussing here. Any query, any question? Okay, so that's all for now. We'll continue inshallah on next Monday, and that will be an on-site class in your department.